Assalamualaikum and a very good day to our panelists, our lecturer Dr. Adi Shams bin Zainuddin and our audience. First of all, I would like to express my thanks to all of our audience. Thank you for attending our online forum for today. Our issue for today is fatigue analysis on Oscar's mountain bike Shimano's crank arm. It is a really great topic to discuss and hear the talk from our panelists here. Ladies and gentlemen, first of all, let me introduce you to our panelists here. At my bottom here, a handsome and intelligent person. Our first panel here is IR Pavitran, son of Mal Vaganan. He is from company Oscar Sendirian Berhad. Next, at my left side here, a beautiful and cheerful person. Our second panel for today is IR Tan Wan Ying. She is a lecturer in mechanical engineering field at University Putra Malaysia. Lastly, I am Wan Muhammad Hafi bin Wan Salihuddin, will be a moderator for today's forum. Before the discussion begins, let me explain about fatigue in crank arm. Fatigue is everywhere. Even we as a human will experience fatigue after repeated activity. Same goes to the bicycle crank arm. Bicycle crank arm tend to experience fatigue failure after repeated cycling process. As we all know, cycling is still a famous activity that people can do during their free time. But less people is concerned about the need to inspect and check their bicycle crank arm. So we are gathering here today to discuss about the analysis we can do on a Shimano's crank arm. Without further ado, IR Pavitran, as an engineer, I would like to ask you the description of the bike that has been a specimen for our forum here.
Okay, thank you, Afi. Here I have prepared a slide to make easier our talk show today. So wait a minute, I will share the screen. Okay. Here is our main topic, which is fatigue failure analysis about Shimano's crank arm from Oscar's mountain bike. Now I'm going to talk about the description part, which means we look into more detail about the crank arm. So here is our content today, such as basic uses, geometry and forces, sample dimension, and materials used to make. Okay. So the first thing about general overview of crank arm. The crank arm is the part of the bicycle drivetrain that translates the mutual movement of the legs of the rider into rotational movement. This consists of one or two sprockets mounted to the crank's arms or crank arms to which the pedals connected. It is attached by the pedal to the rider, to the bike frame by the bottom bracket and by the chain also. Okay. Next, we look into the basic uses of crank arm. So the crank arm is a general reference to all the trains that drive the gears, arms of the cranks, spider cranks, and bottom brackets. So the crank, which known as spider, is the real segment on which the chain rings are bolted, while crank arm is the levers to which you mount your pedals. The bottom bracket is the housing that retains in place the bearings, and the last part is axle, to which the crank arms connected. Okay, then here is the four different angle of photos of Shimano's crank arm of Oscar's mountain bike. So the first picture about first side view, then goes with second side view, and third shows the front view, and last is from the back view of the crank arm. So this Shimano crank arm is much branded and used in Oscar's mountain bike, and this bicycle owned by a bike rider. After that, let's look into the geometry and forces included as shown in schematic diagram here. There are some forces included such as force on chain and force on pedal. So the force on chain is happen due to the force on pedal, which exerted by the rider's feet. Then there are number of cycles involved as the rider pedal the crank arm. Hence, these forces and pressure is exerted at repeated times on the arm will make fatigue failure happen on it. Okay. Next part is about the sample dimension of the Shimano's crank arm. The schematic diagram shows the dimensions in millimeters of the crank arm we choose. So the specialty of this type of arm is a bit shorter and really comfortable to the riders while cycling in any situation, as it is shorter arm, which is 211.05 mm, will give a smaller number of cycles. This means it has a higher effective gear rotation. so we can use less force to travel longer distance. Other than that, it gives us a better biomechanical efficiency and open up more hip angle for more aero position. Okay, here is the last part of the Shimano's crank arm is the materials has been used to make it. As we know, most of arm made by aluminium alloy, titanium, carbon fiber, chromo steel, or some less expensive steel. In BMX and mountain bikes, mostly using the tubular steel cranks, which will give extra strength by cold fogging. Same goes to this Shimano's crank arm, which is made by aluminium and fogging main arms around a hard steel inserted to save weight. So lastly, they are welded before final machining. So I think that's all from my part. Thank you.
Okay, thank you IR Pavitran for the info. So
Yeah.
our crank M is aluminium, length of 211.05 millimeter and is made by Oscar Sindrian Berhad. Next, to our second panel here, IR Tan. As an expert in UPM, can you tell to all of us here how fatigue occur in the crank arm?
Okay, thank you, Abby. So now I'm going to share my screen to show you guys some slides. So since today, the crank arm that we analyzed today is an aluminum forging with hot steel crank arm, and since it's forged with aluminum, the crank arm will undergo the fatigue failure for both aluminum forge and hot steel for the crank arm to fracture completely. So there are total 3 stages of fatigue failure, which are crack initiation, crack propagation, and final fracture. So for the crack initiation, usually it will occur at the region that experiences higher stress concentration compared to other parts. So the crack initiation will be occur to the region that connected to the spider that's shown in this diagram. And since it's connected directly to the spider that link with the chain ring, at this region it experiences the force from the chain and also the cyclic force from the pedal. Obviously, this region has shown a higher stress concentration than others. Thus, the crack initiation will occur at this region. So after crack initiation is followed by the crack propagation. At this stage, the crack will propagate and spread from the origin of crack initiation, and the crack will change the direction and the spread will go perpendicular to the stress applied. And it is a highly noticeable stage as the benchmark is greater at this stage. Eventually, the crack arm fracture when the remaining cross-sectional area becomes too small to withstand the cyclic load applied. And this is the only event that occurs in the final fracture stage. And this stage will occur suddenly without any warning.
Okay, thank you IR Tan for the talk. So basically the stage start with crack initiation and then into the crack propagation and finally the final fracture stage where the crank arm will undergo brittle fracture. IR Pavitran, as we may concern, it is yet impossible to prevent fatigue failure from occur in the bicycle crank arm. Can you give your opinion or talk about the improvement or modification we can do to the crank arm?
Sure. Okay, from my view of for the improvement of crank arm, I would suggest first is anodizing, which is about stepping up version of painting. This method involving electrochemical process that alters the surface of the crank. So I'm very sure it will provide a strong resistance toward scraps or knocks on the bicycle crank arm. Thus, it will prevent further progress of the fatigue failure. And the second suggestion for improvement will be the proper service of for crank arm, which means we have to take care of properly in order to prevent fatal incident. We can say that we need to service time to time and check the condition of the arm so that it will long last without causing fatigue failure. So that's my point for the improvement.
Okay, thank you IR Pavitran. So the ideas are adonizing and proper service of crank arm. This will surely give a better fatigue life to the crank arm. Next, IR Tan, can you share your opinion about the improvement or modification that we can do on the bicycle crank arm?
Sure. So from my point of view, I think that another improvement that can be done is polishing the crank arm. This is because the crank arm that by polishing the crank arm, it can increase the lifespan and also reduce the chance of fatigue failure in crank arm. This is because that by polishing the crank arm, it can reduce the stress concentration on the surface. Besides, it can also remove the scratch that will cause a corrosion, as we know that the corrosion is one of the factors that will promote the fatigue failure. So, secondly, another improvement that can be made is we need to improve the strength of the bite arm. So, it's important at the stage of material consideration. Usually, steel crank arm is found at the older bike, and for the aluminum crank arm is usually for normal use bike, and while for the carbon strength crank arm is for the racing bike. However, aluminum is usually found in the typical normal bike because it has a lower modulus of elasticity that will not lead to brittle easily. So that's all the improvement that I can think about it.
Okay, thank you, Artan. So the ideas are to polish the crank arm to prevent a scratch from initiate the fatigue failure, and the other is a material consideration when choosing the right crank arm. So that's the end
Yes.
for our second round for today. Ladies and gentlemen, as a consequence, I conclude that crank arm should be given more attention from the people out there. Crank arm is one of the important crank arm is the one of the important component of the bicycle, and it also exposed to the fatigue failure. Deep understanding in fatigue failure of a bicycle crank arm is important as crank arm will suddenly experience brittle fracture without warning. Surely, this is very dangerous as it can give fatal injury to the cyclist. So, it's better to understand how fatigue work and to improve the fatigue of the crank arm. I think that's all from us. Thank you.